Hi, professors. This is Erin O'Neill. Talking through quiz 7. Thank you again for giving me an extension on this. Today I made some good breakthroughs. I'll talk through the first row of each of these different situations. So, basically, what is the current leaving the 18-volt battery, the value and the direction? What I did to solve was I started by looking at the diagram and splitting it up into pieces like so. So for switch 1's closed, switch 2's open, I included like where on that circuit the current would be flowing through. So I just omitted this third part. And then in here I included it, but I omitted the first part. Since Ohm's law is V equals I times R, I have this V, and then I needed to find R and I. I have the pieces to find R. I just need to kind of rearrange them into the right formula. So each of these was pretty convenient because every single resistor was 10 ohms, so that made it a little easier to calculate. But so here what I did was I combined this resistor, so taking the inverse, 1 of R and 2 equals 1 over R1 plus 1 over R2, and those are both 1 over 10, so adding that you get 0.20, and then to reverse the inverse, if you will, R12 equals 1 over 0.2, and so that gets you 5 ohms. So right here we have a resistance of 5 ohms, and right here you don't have to do any tricky math because it's 10 ohms. So when I want to find what's the combination of all the resistance, the total resistance resistor, I can do 1 over R12 plus 1 over R3 to get 1 over 5 ohms plus 1 over 10 ohms equals 0.30, and then inverse that again, and 1 over 0.3 is 3.33 ohms. So, taking that's the total resistor, and so like I said before, V equals I times R, so I could rearrange it to find I, so I total equals V total over R total. So plugging in for that, I found 5.40 amps is the total current flowing through 18 volts battery zone. And so I believe that's what I put in for my answer. Yes. And it's flowing clockwise because there's the positive is always flowing because I knew it was flowing that way because the positive side of the battery is up here and the negative side was down there, and because it flows from high to low, so that was its direction. And then for this other one, I kind of started it with the same methodology where I knew that I needed to add this resistor set, this one, and this one to find the total resistor of the current. And so again, I had 1 over R12. I already knew this was 1 over 5, so that made it easy. And then since these two are in parallel, R1, R2, I'm going to just call it R12, is in parallel with R3, and then that is in a series with R4 and 5. I knew that already R1 and R2, or R1 2 is 3.33 ohms, so I knew that this would equal this, and then in series with R4, 5. So 10 ohms plus 10 ohms is 20 ohms. So I can add these together and I get 23.33 ohms. And then again, plug that in as the total R value. I have the total V value as 9. 9 divided by 23.33 gives me the I value, which is 0.386 amps. So that is how much is flowing through here, the 9 amps, and it's going, you can kind of see this is the arrow, it's going this way because, again, positive going to negative. And that's what I put in. Oh, I'm supposed to be talking through 18 for all of them. Okay, well, this one didn't have an 18 volt in its side, so I omitted it. Okay, and then S1 closed and S2 closed. I think this is the row I'm supposed to, yeah, okay, sorry. S1 closed, S2 closed, here we go here. So then what I did was I tried to like simplify. So I started with, this is the diagram. I know that these 3 resistors can kind of be simplified into like their very own, like this, which can be simplified into one single one as it relates to these 2 in a series. And so what I got then was RA and RB. So I call these resistor A, resistor B. And then I called these currents IA and IB. And so I set up these equations and okay, I just have to remind myself I'm talking about. Oh yeah, what the current was through the 18 battery with them closed. Okay. And so set up the equations that I know because this is the total volts, and then I'm subtracting IA and RA, but I'm adding IB and RB, RA. And so I set that up to equal 0, and then 9 volts plus 1B RB plus, or sorry, IB RB plus IB RA minus IA RA equals 0. And so I realized that these 2 are the exact same. So I could basically just cross them out and then have them equal each other. So 18 volts equals 9 volts plus IB RB. So I rearranged it so that we'd get just 0 on one end. And then I rearranged it again to get IB by itself, which would give me the current going through this side. And when I plugged my numbers in, I got 0.45 amps flowing through the, oh yeah, IB. Is that what I said here? No, I think I was just talking through the 9. Sorry, I was talking through the wrong one. Well, if you're still listening to this, you have a lot of patience. Sorry to be so slow. Okay, so I got 5.855. So I'm talking through this one. Oh yeah, well I had to find that. I had to find IB so I could get IA. Because I'm not talking about the 9 volt, I'm talking about the 18 volt. Geez, okay. As you can see, this is still kind of like acrobatics for my brain cells to do. So IA, I could plug in my IB for IA. Well, here, this is what I did. I returned to this equation that I had up here. I rearranged it, to get IA by itself. And now I knew what IB was, so I could plug that in to solve for IA, which is 5.855. And then I knew I could just divide that by, or subtract it by the difference, and then divide it by 3 to get the amps per current. So anyways, 5.855 amps is what I got. And then if I want to talk through these three. Let's see, which one is it? Here you are. Here's my guy. Yep. So I want to talk through them all again. And this is open. There's 5.4 amps flowing through, going clockwise. I guess one question I have is this still clockwise on this side? Because like it looks almost like it's turning this way, which would be counterclockwise, but like in the grand scheme of things, it's still like moving around clockwise. So I think it's still considered clockwise. Anyways, so there's that one. Here it's now 0 because the current's not getting there. And then when they're both closed, the current is 5.85. So mine was another 5. I would have rounded to 5.86, but whatever, close enough. Okay. Woo. So there it is. Okay. Thanks for hanging out.